Equations of lines in the coordinate plane. So this is a review from Algebra 1, but we just want to brush up on some of this before we add to it in our next lesson. Slope and rate of change. Slope, represented by the variable m, is the ratio of the vertical change to the horizontal change of 2 points from left to right on the coordinate plane. So slope, most familiarly, is rise over run. And if you think about the rise, that is the change in the y-coordinates. So when you rise, think about you're changing your position up and down. And so that's going to be your y2, your second point, minus the y-coordinate of your first point. So that tells you the change in the y-coordinates and the change in the rise of the 2 points. The run, you run left to right, horizontally on the ground. So that's the change in the x-coordinates. And again, it'll be the x-coordinate of your second point minus the x-coordinate of your first point. Now when we talk about certain types of slopes, okay, from left to right, if your line is going upwards, we call that a positive slope. From left to right, if your line is going downwards, we call that a negative slope. If your line does not go up or down, but it's just horizontal, it's a zero slope. And if your line just goes straight up and down and is vertical, then we call that an undefined slope. Now let's work out a few examples finding the slope of a line. So when you're given 2 points from the coordinate plane, x1, y1, and x2, y2, we're going to find the slope by using the following formula. So if you need to start off by labeling your points, x1, y1, x2, y2, do that so that you don't mix up your numbers. So let's start off with y2 minus y1. So our y2, 6, minus our y1, negative 2. Now remember, minus is in the formula, so if you have a negative number, you're going to end up with a double negative, and we'll address that in a minute. And on the bottom, we have x2 minus x1, so that's 2 minus 4. Now on the top, again, that double negative means it's plus a positive, so we actually have 6 plus 2 is 8, over 2 minus 4 is 2. So 8 over 2, this is going to give us a slope of equations of lines in the coordinate plane. Slope and rate of change. Slope, represented by the variable m, is the ratio of the vertical change to the horizontal change of 2 points from left to right. So hopefully you remember from Algebra 1 the idea of slope, and you should initially think of rise over run. Now the rise, remember, is the change in the up or down, which is the y-coordinates. And the way we represent the change in y-coordinates is y2 minus y1. So you take the y-coordinate of the second point, subtract the y-coordinate of the first point. Then the run, you run horizontally left to right, so that represents the change in the x-coordinates. And we find that by taking the x-coordinate of the second point and subtracting the x-coordinate of the first point. So when we look at the graph from left to right, if our line is going upwards from left to right, we call that a positive slope. If the line is going downwards from left to right, we call that a negative slope. If it just goes straight across horizontally, that's a zero slope, and straight up and down vertically is an undefined slope. So let's do a little practice finding the slope of a line when we're given 2 different points. So 2 generic points, x1, y1, and x2, y2, you find the slope using this formula, as we talked about on the page before. So if you need to label your coordinate points to start, x1, y1, x2, y2, to make sure you put them in the correct place, that's fine. So let's go ahead and find the slope of the line that goes through these 2 points. y2 is 6 minus y1 is negative 2. Now remember, subtraction is in the formula, So if you have a negative number, don't forget to add that negative as well. Over x2 minus x1. Now as we simplify this, minus a negative becomes plus a positive. So in the top we have 6 plus 2 is 8, and then on the bottom, negative 2 minus 4 gives us negative 6. Now it doesn't divide nicely, but what we can do is simplify. So the top and bottom are both divisible by 2, so this actually becomes negative 4/3 for the slope. I want you to go ahead and pause, try this second example, and then check back with me when you're finished. Hopefully you have negative 3 minus 3 on top, 1 minus 7 on the bottom, which is negative 6 over negative 6, and that simplifies to a slope of positive 1. Forms of linear equations. In Algebra 1, you're probably most familiar with slope-intercept form. Slope-intercept form is an equation of a line written as y equals mx plus b. Now in this form, we're going to replace m with the slope and b with the y-intercept. However, x and y will remain as variables in the equation. Some of you might have learned point-slope form before, but if you haven't, you're going to want to pay attention to this. Depending on what information you're given, when you're asked to write an equation of a line, point-slope form can be faster at times. So I want you to know this formula: y minus y1 equals m times x minus x1 inside parentheses. So again, the slope is still represented by m, so we are going to replace that variable m with the slope. And then, just like in slope-intercept form, the variable x and y need to remain as variables in your equation of the line. So that means we're going to need to substitute this x1 and y1. So all we're going to do is substitute the x-coordinate of the given point for x1 and the y-coordinate of the given point for y1. We'll work through some examples showing you how to work with point-slope form. Slope-intercept form. So we want to identify the slope and the y-intercept of the following lines and then graph each line. So don't forget, in slope-intercept form, we want the slope and the y-intercept. Now, if you take a look at both of these lines, they are not written in slope-intercept form. So the first thing we want to do is change them so that they are in slope-intercept form so that we can easily identify the slope and the y-intercept. So our goal is to get y all by itself on one side of the equal sign. So first, let's add 4x to both sides so that we can cancel it out over here, and we're left with 2y equals 4x plus 2. And then to isolate y, we want to divide by 2, and we need to make sure to divide every single term. So we divide by 2, and then we have y is equal to 2x plus 1. So again, we're going to have a slope of 2 and then a y-intercept of positive 1. So that's the information we need to look for, and then now we can graph our line. So first we plot the y-intercept, positive 1 on the y-axis, and then a slope of 2. And remember, that's really 2 over 1 for rise 2, run 1 to the right. And then once we have that, we should be able to connect those 2 points for our line. Now I want you to pause, do the same thing with example 2, and then check back with me when you're. Hopefully first you subtracted x from both sides, and then to isolate y you divide each term by 2. Now this becomes y, and then a negative x over 2. Remember, there's really an invisible coefficient of 1 right here, so it's actually negative 1/2 x plus 8 divided by 2 is 4. So our -1/2 is our slope. Positive 4 is our y-intercept. So you plot positive 4 on the y-axis, and then you count down 1 to the right 2 to plot your next point so you have a negative slope. Next, we want to talk about point slope form. So remember, this might be new for some of you, but again, you are going to want to learn this. It can help you write your equations of lines much faster in some cases. So just remember what they stand for, the variables. M is the slope, and the x1 and y1 are the given point. So our task is to write an equation of a line given the slope and a point. So here, they tell us that the slope is 2 and it passes through the point 3, 5. So we're going to put that information into our equation of a line in point slope form. Y minus the y coordinate, 5, equals m times the x minus the x coordinate, 3. And that's it. That's all you have to do. If I don't specify what form of equation I want your line to be in, leaving your answer in point slope form, just plugging in the information, is perfectly fine. Now I want you to try example 2 and then check back with me when. Now, hopefully you got y minus 3 equals -1/2 times x minus 2. So again, if I don't specify what form I want your equation of a line to be in, you can leave it in point slope form. Lastly, we just want to talk about certain important lines to remember. And I want you to remember this term, hoi vux. Now what this is going to help you remember is that horizontal lines have a 0 slope, and the equations are written y equals. Vertical lines have an undefined slope and have an equation written x equals a number. So let's go ahead and graph these lines. When we have the line y equals 2, you're going to find y is positive 2. And then remember, when it's y equals, it's a 0 slope horizontal line. So we're going to draw in a horizontal line right here. And there's our equation. In example 2, it says x equals 0. So we're going to find where x equals 0, and that's actually right here. When you have an equation x equals something, it's an undefined slope and a vertical line. So this line is just going to be straight up and down. I want you to go ahead and pause, try example 3 and example 4, and check back with me when you're finished. Hopefully you plotted y equals 0, and then remember y equals means it's a 0 slope horizontal line. So we have this line for y equals 0. X equals -1. You find -1 on the x-axis, and then x equals is undefined and vertical, so you draw a vertical line through that point -1. That's it for these notes.